Methane hydrate is very much like what water ice looks like. It's a solid, cold substance, but of course the difference is it has methane gas. And it's really only stable at unique conditions. You can't really have it exist here in atmospheric conditions. You got to have really high pressure and cold temperatures, like we have directly underneath of us in the bottom of a deep ocean, before the sediments get too warm. So there's this Goldilocks window where hydrate is stable. We understand those conditions pretty well, and what we're trying to do now is recover it and study it, but that's more challenging, as we're finding out.
Methane hydrate is frozen methane. And we find frozen methane all over the world. There's a lot of it, but we actually really have a really poor understanding of how much there is. We know there's a lot, but our estimates vary by what we call orders of magnitude, which is 10 times 10 times 10 times 10. We're actually 4 orders of magnitude off. And if we take those numbers and then try to plug them into like how carbon moves over the entire Earth, that creates a lot of uncertainty with how much impact releasing or storing methane hydrate can have. So one of my big questions is to try to figure out how much hydrate there is on Earth, and I need to understand how systems like this work so that I can understand how the larger system works.
There was initially, in the history of hydrate research, there was a lot of excitement, I would say, or at least concern that hydrates could catastrophically destabilize and go right to the atmosphere and bring lots of methane to the atmosphere and warm the climate. In the last, I would say, 20 years easily, we've come to realize that most of that methane is probably going to get consumed in the ocean and become CO2, and very little of it would make it out to the atmosphere. And another kind of realization is that there's not a way to really destabilize a lot of it all at once. The most exciting part of marine geology is when you can go out and explore and get new information about the environment you're studying. And a lot of that can happen in the water column, it can happen on the seafloor, but when you get to go back through time, for me, that's the more exciting aspect. We can start to reconstruct how the ocean changed through time. And to me, that's probably the most exciting thing. That's reason to be out here, is because we're expanding our knowledge by going back in time, potentially, and sort of reconstructing that. History is our challenge as sedimentologists.